Hello everyone, my name is Ankit Verma and today we are learning the example of deterministic finite automata, which is DFA. So here construct DFA of language with all strings of length 2 over sigma equal to a comma b. So here the important thing is string of length 2 means those string which contain length 2. For that language we are going to construct the DFA, and here the alphabet given is a comma b. So first of all we are taking this sigma equal to a comma b. Here a comma b are symbols and sigma is alphabet. Alphabet is set of symbols which are given as a comma b. The meaning is that we are going to construct the string from a and b which should be of length 2. Now we are going to generate the language. So here I am taking L. So here L signify the language. And the language is set of all string of length 2. So that is equal to the set. Here the language is the set of string and here the string are of length 2. We have to generate the string from A and B. So the possibilities are, the first string is from A we can generate 2 times A, or from AB we can generate AB, then from AB we can generate BA, and we can also generate from B, that is BB. So there are 4 possibilities. That means the string of length 2. So there are 4 possibilities which we have mentioned. Now these are the string which are of length 2 and these are generated from sigma equal to a comma b. So for that language we are going to generate the DFA. DFA always has the initial state. So here I am mentioning a initial state which is represented by a circle with the incoming arrow. This is the initial state. Let us assume that this state is given the name which is Q0. Now we are designing the DFA step by step. The first step is we are going to find out the string which is of minimum length. But here we can see that all are of length 2. So we can pick any of the string at random. Let's say I am taking this AA. We know that the DFA change its state for every input. So here we are starting with Q0 and let's say the first input is coming which is A. So for that input A, DFA is going to change its state, means going to the next state. So after getting this A, is this string is accepted? No. There is one more input available. That means after processing this A, the string is not yet accepted. So this is not the final state. This is a normal state. So here I am drawing another state. Let's say the name given to this state is Q1. So for the first A, state gets changed, means from Q0 to Q1 we are here. Now for next A, again the state will change. So here we are on Q1 and next A is coming. So DFA is going to change its state, means going to the next state. Now we should check that after scanning the next A, is this string accepted? Yes, the string will be accepted because after 2A we should accept it. Means this state will be the final state and that is represented by double circle. So this is final state. Here we are giving the name to this state, that is Q2. So for this string, when A is coming, so from Q0 we are on Q1, Then next A is coming, so from Q1 we are on Q2. So after processing this string, we are on the final state. That means this string is accepted by the DFA. So the skeleton of DFA is created. Now check, is this DFA complete? DFA will be complete if all the states are addressing the input symbol, which is A and B. So for all the state, we should be having the moves for A and B. At Q0, we are having move for A, but B is missing. For Q1, we are having move for A, B is missing, and for Q2, A and B, both moves are missing. So this DFA is not complete. We are moving further. Let's take the next string, which is AB. So if A is coming from Q0, we are coming to Q1. And if B is coming, then in that case, we should accept this string. That means after A, if B is coming, we should be on the final state. So for first A, we are on Q1. Then for B, we should be on final state. That means if I put comma B here, then this will solve our purpose. So for first A, from Q0 to Q1, then for B, from Q1 to Q2. This is the final state. That means this string is accepted by this DFA. Here we can see that on Q1, for A and B, both moves are created. Now we are moving further. Let's suppose that we are taking the string which is BA. So if first B is coming, then we are on Q0, but here the move is not defined. So we has to check the possibility. The first possibility is that when we are Q0 and if B is coming, we can create the self loop. That means if B comes, we are coming back to Q0. But let's check. If B is coming, we are coming back to Q0. And if further A is coming, we are on Q1. So after complete scanning this string, we are on Q1 and this is not the final state. So this is wrong. We have to check some other option. The second option is that we are on Q0 and if B is coming, we may go to the dead state. Dead state is a state that means this B is rejected. And afterward, if any of the A and B is coming, then we are keep on rejecting. But if by simply checking the first B, if we are rejecting a string, so here BA and BB, because they start with B, they will be rejected, which is wrong. So this is not solving our purpose. We have to try some other thing. There is one more possibility. We are on Q0 and if B is coming, then we should be going on Q1. Let's check. So here, if first B is coming from Q0, we are on Q1 and then A is coming. So from Q1, we are on Q2. So here we are on final state and this is solving our purpose because after scanning this complete string, we are on the final state. So this string is accepted by the DFA. Let's check another string. So here we are having B. So we are on Q0 and if B is coming, we are coming to Q1. And then again B is coming. So from Q1 we are on Q2. So here we are on final state. So after scanning this complete string, we are on final state. That means this is also accepted by the DFA. Here we can see that in our language, there are 4 strings and all these 4 strings are accepted by the DFA. So is this DFA complete? We should check it. In first state, which is Q0, if A is coming, we are on Q1. If B is coming, we are on Q1. So that means Q0 is complete. Now check the Q1. When we are on Q1, if A comes, we are on Q2. If B comes, we are on Q2. That means Q1 is complete. But on Q2, for A and B, if they come, there is no move available. So still this DFA is not complete. We has to move further. Let us suppose that on Q2, when A is coming, we are thinking that there can be the option that we are going to apply the self loop. So let's check. Let's take example of a string. Let us suppose we are having A. So 3 times A. We know that our language is of length 2. So string which should have length 2. But here there are 3 symbols. So string of length 3. This is not the part of our language. Let's try this string on the DFA. So when the first A is coming, we start the DFA from Q0 initial state, and for A we are going to Q1. For next A we are going from Q1 to Q2. Now for the next A we are coming back to Q2. That means this is the final state and this string is accepted. This is wrong, because this string is of length 3 and this is accepted by the DFA, which is not right, because our DFA should only accept string of length 2. So this is not solving our purpose. We should try some other thing. There is one more possibility, that we are on Q2 and if A is coming, then we go to the dead state. The dead state means from where we cannot proceed further. In the dead state, if further any A or B is coming, then we always have a self loop, means we are stuck in this state. So whenever any A and B is coming on the dead state, we are keep in a loop and we are moving on the same state. So this is called the dead state, where we have the self loop for all the symbols. So here we cannot move further. This is the dead end. Let's check, is it solving our purpose? So here, if the first A is coming from Q0, for A we are moving to Q1. If next A is coming, so from Q1 for A we are going to Q2. And if next A is coming, so from Q2 for A we are going to this state. And this is not the final state. That means this string is not accepted by this DFA. So this is right. This is solving our purpose, because this is of length 3 and this should be rejected. So this move is correct. Now this state I am giving the name, which is Q3. I am testing one more string. Let's say the string is BAB. We know that this string is also not the part of language, because this is of length 3 and our language is of length 2. So this is not the part of language. This should be rejected by the DFA. So let's check. So for first B, here we start with Q0. For B, we are going to Q1. Then if A comes from Q1, for A, we are going to Q2. And if B is coming, then here we are going to provide the move for B. We know that this is of length 3. This is the same case as the previous case. We have the length 3, just like AAA. And this should be rejected. So I can put B here. Now let's check. Is it solving our purpose? When first B is coming, then from Q0 for B we are going to Q1. When A is coming, then from Q1 for A we are going to Q2. And then B is coming. So from Q2 for B, we are going on Q3. So after scanning this complete string, we are on Q3. This Q3 is not a final state. That means after scanning the complete string, we are not going to final state. That means it is not accepted by the DFA. So this is solving our purpose. Let's check, is this DFA complete? So at state Q0, for A and B, both moves are available. At state Q1, for A and B, the move is available. Then at state Q2, for A and B, move is available. At Q3, A and B, move is available. So all the states are addressing the input symbols A and B. So this DFA is complete. And also this is accepting the string of length 2 and rejecting all other string. So here we have successfully created the DFA for the language which is having the string of length 2. So that's all for today. Thank you.